Assalamu alaikum and welcome to another video of Learn with Laraib. So before we start today's topic, I'd like to tell you the answer to the question in the previous video. It was mitral stenosis. If you learned something, please subscribe to the channel for more. So starting off with today's topic, which is action potential and ECG. Let's discuss myocardial action potential. So here's the diagram and the color corresponds to the explanation. So the first phase, phase 0, is depolarization. What happens is that the sodium gated voltage channels open and there is a sodium influx, due to which the potential rises and there is an upstroke making depolarization. Next phase is potassium efflux causing repolarization. In this, the voltage gated sodium channels close and there is a minimal potassium efflux causing repolarization. And then what happens is there is a plateau phase. This plateau phase is caused through a balance of potassium efflux and calcium influx, which triggers calcium release from sarcoplasmic reticulum and myocyte contraction. This is the excitation contraction coupling. The third phase is rapid repolarization. This happens due to massive potassium efflux due to opening of voltage gated slow potassium channels. And after this, the membrane potential will be reached by potassium efflux. So, this was your action potential. And for the resting membrane potential, it is through highly permeable potassium channels. Now, the pacemaker potential. In pacemaker potential, there is no phase 1 or phase 2. It starts off with calcium upstroke, unlike the sodium upstroke in normal action potential or the cardiac myocyte action potential. So, sodium channels over here are permanently inactivated, and instead, the voltage gated calcium channel opens and there is a calcium influx. Phase 1 or 2 are absent, and then in phase 3, there is a potassium influx causing repolarization. In this phase, there will be inactivation of calcium channels and then obviously activation of potassium channels. This is then followed by a slow depolarization, which is also sometimes known as funny current. Slow depolarization is due to an increase in conduction of sodium ions. So there is a mixed sodium potassium influx. This is basically what accounts for pacemaker activity. Now, one thing I would like to tell you is that there is a larger refractory period in the cardiac myocyte action potential as compared to normal skeletal muscle action potential. Therefore, the cardiac muscles cannot be tetanized because they have a long refractory period. Okay, now let's discuss ECG. Okay, so to discuss ECG, here's a diagram of the heart showing how the conduct. Okay, so here is a diagram of the heart which shows how electrical activity is conducted across the heart from SA node to the atria to the look at the diagram, and then from AV node to the bundle branches and Purkinje fibers in the ventricle. So let's see the ECG diagram in correspondence to this heart diagram. Please note that the colors in action potential and ECG are not corresponding. That was different, this is different. I'll explain how action potential and ECG are linked though. This is a typical ECG diagram. So now when I explain ECG, please look at both the heart diagram and the waveform. So the P wave denotes atrial depolarization, which is further denoted by phase 0 of the action potential for the atria. So the current is spread from SA node to the atria and depolarization occurs, shown by P wave. Then there is AV nodal delay, or basically the time taken from atrial depolarization to ventricular depolarization to start. That is represented by PR segment. the blue one over here. This is the physiological delay. Now, when the electrical activity is conducted towards the ventricles and the ventricular depolarization occurs, it is represented by the QRS segment. After which, there is an ST segment, which is an isoelectric phase, and the T wave for repolarization. The U wave is not always present, it is only present in hypokalemia and bradycardia. I have written it as hypokalemia for you to learn it. Okay, now let's discuss ECG in a bit detail. So starting with the P wave, as we just mentioned, it shows atrial depolarization when the current is conducted from SA node to the Bachmann bundle in the atria as shown in the heart diagram. So please remember, whenever there is an electrical activity as shown in the ECG, it is then followed by a mechanical activity. So every electrical activity will then prompt a mechanical activity. So P wave will correspond to atrial systole. And when there is an absent P wave, there will be an absent atrial systole. A lot of people confuse between PR segment and PR interval. As I just told you, PR interval is the time between atrial depolarization and ventricular depolarization, which is basically the AV node conduction. So, when there is an increase in PR interval, that means that the conduction is slowed down. This can be one thing. And the other thing is there is an increase in parasympathetic activity. So, when the parasympathetic activity increases, the heart rate decreases because there is an increase in PR interval. Okay. So, the PR segment over here corresponds to which JVP wave segment? The answer is A wave. Now, if you want much further detail on JVP wave, you can watch my video on cardiac cycle and JVP. For now, let's move on to QRS. So, for QRS represents ventricular depolarization, which will then be followed by contraction. So, the QRS wave, there's an MCQ, it will correspond to. Please note that it does not mean ventricular contraction, it will correspond to ventricular contraction. QRS wave itself means ventricular depolarization. Now, the QT interval from the start of Q wave till the end of T wave, it shows the ventricular depolarization, mechanical contraction, and the ventricular repolarization. So, the QT interval is what is actually complete ventricular systole. So, whenever there is a question asking for complete ventricular systole, that will be in QT interval. There's always a question asking what is the wave or a peak which corresponds to ventricular systole, that will be R wave. So, as we have discussed, QRS represents ventricular depolarization, and the T wave and the ST segment represents ventricular repolarization. So, in short, the QT interval is the total time of ventricular action potential from sodium influx to potassium mediated recovery, or basically the RMP. Now, what is the role of calcium in this? Calcium shortens or prolongs the plateau phase in the action potential for a cardiac myocyte. So, if there is more calcium or an increase in calcium, the contraction will happen early. There will be a shorter plateau phase, due to which there will be a shorter QT. So, hypercalcemia causes a short QT. On the contrary, hypocalcemia causes a prolonged QT interval. Now, what other conditions are there which cause prolonged QT? One of them is hypoglycemia, and there are a few other. They can be learned via this mnemonic A, B, C, D, E. A is for antiarrhythmetics, B is for antibiotics, C is for antipsychotics, D is for antidepressants, and E is for antiemetics. Okay, now moving on to a few QRS pathologies. So, QRS, as I just told you, is when there is an electrical activity in the muscle of ventricle causing its depolarization. When there is a high amplitude of QRS, it means that there will be more electrical activity which would occur when there is more amount of muscle, which occurs in hypertrophy. Now, for low amplitude, obviously there will be less amount of muscle. So that is possible commonly when there is a history of MI. So an old MI will show a low amplitude QRS, whereas hypertrophy of the ventricle will show tall or high amplitude QRS. Now there is an MCQ which is confusing. It says the wave of depolarization travels from endocardium to epicardium in which phase of ECG? So the answer to this is QRS complex. The question is why not the P wave? उसमें भी तो depolarization हो रही होती है. It's not P because atria does not have a well layered muscle structure like ventricles or any penetrating Purkinje fibers. So the P wave mostly reflect right and left, superior and inferior across the atria. That is why the answer for this will be QRS. Now coming on to ST segment. ST segment, as I just told you, is the plateau phase. It is an isoelectric phase and it is related to entry of calcium. So ST segment is characteristic for ECG change in MI as there is displacement of ST segment in leads overlying infarct. We'll learn this more in detail in next videos. So we're done with P wave, QRS complex, PR interval, PR segment, QT interval, ST segment. We'll move on to T wave. T wave, as we have discussed, denotes repolarization, which is ventricular repolarization. So this is atrial depolarization, this is ventricular depolarization, atria भी contract हो गया, ventricle भी contract हो गया, ventricle depolarized भी हो गया. The next step is ventricular relaxation or diastole. So the T to P segment will represent ventricular diastole. Before I end today's video, I would like to tell you another bonus point. The electrical activity which is not recorded on ECG is the electrical activity of SA node. Alright, so that's a wrap on part 1 of mastering ECG. We have linked action potential with ECG waves to build a solid base. In part 2, we will learn how to decode ECG based on the pathology. If this helped you, like, share, and subscribe to Learn with Laraib and drop your ECG doubts in the comments. On to the next one. Let's keep learning together. Thank you.